frame you see here is 65 feet 8 inches long. When completed, it'll be about 70,000 pounds on it. It goes back to a shop in Ohio on Monday, in which they'll get much more of the steel put onto it, and I will have 10 guys welding on it, pretty much solid now, and to have completion sometime by the 4th of July on that. This will be completed, and at that point we'll start on the cylinders next, and manufacture the cylinders and mount the cylinders to the locomotive when it comes down to it. We also brought along with us 4 of the 7 wheels we have. So we have 7 wheels totally cast. Here are 4 of them. We call this the Nikini family. We survive and operate via donations. Is how we're doing all this. This is 100% funded by rail fans and like-minded individuals. And Paul was one of those guys that has a love for railroading. He believes in what we're doing and stepped up. And each driver costs $25,000 sponsorship to have his name on it. And there's 4 of them here on that. So he made a $100,000 donation to us to get these 4 drivers cast. The cost of the frame, we'll have about $300,000 in the frame when it's all said and done. If we'd have gone with a one-piece casting frame, it'd be about $3 million to have that done. We did locate a shop that would do it for us, but it was not feasible to do it when it came down to it. So we can save $2.7 million by going to this style. Guess what we're doing? Going with this on that. This form of construction allows us a massive advantage over the castings, is that we can machine everything as we go and weld it in place, so that we don't have to, when it's all done, go and machine the entire thing up down. So this is an example of those parts. So these pedestals on here, these are machine components, very critical to the operation of the locomotive. They go inside these jaws here. There'll be like a U that goes in there, and one of the drivers will sit right in front of here, and that's what goes up and down in the wheels. So the importance of this is the front to back, so you want to keep your center to center of the wheels within very tight tolerances, stop on wear, and then also motion, back side-by-side motion is very important as well. So that's why these are super critical in the construction of the locomotive. And then these will get welded in here, and there's a whole bunch of steel that still get welded in the middle. When it goes back to the shop, it gets put in. There's extra steel that's put to be on the front and back. We did not put that on here because if we would have brought it on here, we would have had to mount the frame about 4 feet higher than it currently is, which is a nightmare for the trucking part of it, and strapping it down while you're going down the highway. Took us 5 hours to get here with the truck, so that would have been a little hairier situation to do it. So we did it this way so we can keep it lower to the trailer and keep it easier to move around on us here. So the parts get heavier and heavier the further along we get on this project, by far. So each wheel weighs about 3,000 pounds on that, so there's 12,000 pounds of wheels there. And what's interesting about it is it's got counterbalancing, so that if you go take your car and go get new wheels put on it, and they put wheel weights on it and balance all the wheels, but we have to do the same thing with these big wheels. Inside these pockets, we'll get lead shot put in there, so little BBs basically in there. So as it goes around, that lead shot will move around to help balance out the cross balancing on the wheels to level even it out. And then there'll be plates that'll get put welded back over top of that to keep that shot inside there. And then every 4 or 5 years, you're gonna pull them plates off and replace the lead inside there, because it basically turns to dust, getting beat around over the time. So on that, and then each wheel will get a tire put on it. So right now the wheels, as they sit, are 72 inches in diameter. They'll get a 4-inch tire, which will make them up to 80 inches when it's all said and done. So they're still not fully grown yet. They'll add to it and become even bigger. We want to put them the way that the locomotive would be set up. It's unique, and it's a 4-4-4-4 arrangement. For those familiar with a typical 4-8-4, the Penske, like, they couldn't do anything typical like everybody else, so they took a 4-8-4 design, and they put an extra set of cylinders in the middle to make it even more powerful and faster locomotives. Again, back in the 40s, their number one competition, everybody says New York Central was their competition. That is wrong. Their main competition was TWA, the airlines, starting passenger service and flying around the country. So they're trying to compete with them. Hence the streamlining of this locomotive. They're competing with the DC-9s and airplanes at the time. That's ultimately what put the railroads down, not necessarily the railroads themselves. And the interstate highways was a big part of that. So, but which ultimately then went to diesel locomotives, but steam still rolled when it came to speed. Steam would outrun the diesels any day of the week on that. We'll walk everybody back to the front here. We'll basically just do a U around the locomotive here, and we'll kind of talk about different parts of it, some points of interest. Anybody has any questions along the way, throw them hands up, and we're more than happy to answer them and explain it. We as an organization believe heavily in transparency. We want everybody to see what we're taking. Your donations, when you buy a hat or make an online donation to us, we want you to see what we're doing with that money, and we're turning it into steel. I tell people that's my job here with the organization, is I take your money and I make sure the bank account stays as close to zero as possible, because I want to take that money and turn it into steel. So that is the exchange rate that we're doing, and we have 1 million pounds. The locomotive is 1 million pounds when it's all said and done. So we just continue to do that and turning into steel. And parts keep getting bigger and bigger, heavier and heavier. And I'm not sure after this if we're going to be able to bring these big parts back over here to Central PA. Most likely we'll have to have you guys come to Ohio where we'll be assembling it to actually start seeing it, just because the sheer cost of moving it is substantial on that. So we hope within the next 2 years to be able to take and put the frame on 4 completed driver wheels with axles on it and set the boiler on top of the frame. So if all goes well, the next 24 to 30 months we'll be in that position to do that. It all goes to the speed of fundraising and the money coming in to make that happen. And again, working with the shops that we're working with, a lot of them have lead times of 24 to 36 weeks on that. So you're 6 months out to get shop time in. So we have to utilize that shop time when we get it to get stuff in there and get it done and get it out. So we knew we needed some stuff. We needed appliances, what we call appliances. That's air compressors, steam generators to produce electricity on the locomotive for our radios and headlights and all that stuff. And then we also needed injectors. Injectors are used to take 300 pounds of steam that's in the boiler, take the water from that's in the tender, it speeds that water up and puts it inside the boiler. So as you boil water off to make steam, you need to replenish that in there. So you have to inject the water into the boilers on that. This locomotive, being a massive locomotive and a massive sized boiler, needs a big injector. There's no manufacturer of these injectors left. There's companies that manufacture smaller ones for industrial boilers and stuff like that, but nothing for the size locomotive that we need on that. Our goal was just to go, hey, we're going to go to XYZ museum that has a display locomotive. We're going to do some horse trading with them, get their injector off that locomotive, and they'll let us use it. Well, the problem is we're about 30 years too late. All the other operators of big engines had the same idea as we did, so they've gone and stripped out all the good parts off of all those injectors that are on display, so there's nothing really left. The guys that are out there operating now are operating on old stuff, and they're just shoestringing them along to get them, keeping them running. So what we did was we approached all the big steam operators in the country, everybody from the Union Pacific, Fort Wayne Railroad, 611, all operate these big locomotives. Went to them and said, listen, if we manufacture, we'll do all the heavy lifting, we'll do all the engineering, we'll do work with all the shops, we'll do everything. Would you be interested in going in with us to buy a brand new one and have it completed? Before we even got that sentence out, they said yes. That's how desperate they are. So what we've done is we're not in this to make any money. We're doing the whole project. Say, here's the cost of the project. Everybody wants one, tell us how we want, and we divide that out amongst everybody evenly on that. So no one's paying more, no one's paying less. We all take the burden of the cost. So to make an injector is going to be somewhere around $45,000, $50,000 each. Had we decided to make 2 for ourselves, it'd probably be $90,000 to $100,000 each for us to do that. So we'd have 200 grand in 2 injectors for this locomotive. Now we'll have them for well under 100 grand for this locomotive. and be brand new and with spare parts easily available as well. So that's worked out well. So after talking to all those guys, we end up having 12 of them that are going to be made on this, and we'll probably make a couple extra body castings up just to have them on the shelf, so somebody else decides later they won't be paying $90,000, probably be $50,000 or $60,000 at that point for the next round of them, but at least it'll be a reasonable amount. So we go through this whole process, create the injector, create the patterns, send off everything to the foundry. We expect that we'll have the first body casting sometime end of June, early July. We can machine it up. Fort Wayne's allowing us to put it on Nickel Plate Road 765 in September. They're going to give us time to go and put it. They have one on their engine. We'll just unbolt theirs, bolt ours in place, and use it and test it and make sure everything works properly. All the lifts are good and correct on it. And then we'll manufacture the rest of them. And then first quarter next year, we'll ship everybody their injectors. So we have multiple different engineers and machinists working on the project for us to get everything developed. And then, interesting enough, when I got to the hotel on Thursday, there was a big box there waiting for me at the hotel. Go and say, what is this? Check it out. I go over there. One of the machinists taken and 3D printed the injectors that were off of our drawings. So we take 2D drawings and made 3D models of that. They took the 3D models we made of that and sent to the foundry to make all these parts, and 3D printed it out of plastic. And sent it. So to my knowledge, it's the only one in existence on that, but that was a nice surprise to find at the hotel on this. So this is what the injector looked like. These will hang on the back side, underneath the cab, back here, underneath the engine. And the engineer will have one, the fireman will have one, and the engineer side will have a nozzle in to put 9,000 gallons per hour in it. The fireman will have one that's 12,000 gallons per hour. So that meets and exceeds what the original T1 feed water system had in it. So there should be no issues there. And same setup that C&O 614 had on it, and it ran 80, 90 miles an hour all day long on back even in the 1990s on that, and with no issues whatsoever. So that's been a big part of it. You can see the step down here in the back. That's for the firebox. The firebox drops down, and then the openings for what would have been the ash pan, which now this locomotive is no longer be coal burning, it's going to be oil burning. So we'll have all the oil pan underneath there to catch it, which will be a bunch of fire brick underneath there, and then somewhere right up here in the front, a big burner blowing in there and blowing the fire in as it operates down the tracks. Again, that was mainly done for the ability to run. So we had not a lot. We had a few people that chastised us about not keeping it cool. But the reality of it is, all right, if we keep it cool, it's going to be sitting. It's not going to be running. We go to oil, then we have the opportunities to run this thing are greatly improved on it. Short lines, Class 1 railroads, museum operations, doesn't matter. It makes it a lot easier for us to operate and run it. So it was kind of a no-brainer on that. Believe me, we wanted to stay as a coal burner as bad as anybody else. But the reality of it is, as an oil burner, it's just a better option. And it makes life a lot easier for the crews, scheduling, and where we're going to take it. So you'll see pretty much all the other big engines in the east, maybe other except for the running in Northern 2102, will probably be converted to oil at some point in the next 5 to 10 years. It's just the world we live in now. So, any questions on this side before we move over to the other side?
What's the well? How can you guys? Where are you guys gonna operate?
We have many invitations to operate this thing everywhere from Michigan, Ohio, Pennsylvania, up in New York, even down to the Carolinas, on called Class 2 regional railroads, Indiana as well. You'll probably see us operate on the Indiana Northeastern Railroad quite a bit over there. Up in Michigan, Steam Railroading Institute, Great Lakes Central Railway, Steamtown up in Scranton on that. And then we'll use the big railroads to get between places. Whether or not we do trips or run train rides on the big railroads is yet to be determined. The thing you have to understand about the big railroads, the Norfolk Southerns, the CSXs, and UPs, management changes every 4 years in those organizations. So for us to sit down and have those conversations today would be pointless, because the people that are in power making decisions today won't be in power making decisions 6 years from now. So our plan still is 2030 for completion of Locomotive, and we're on pace to have that done. So again, as the parts get bigger and we get more stuff done, we'll see donations come in more rapidly at that point. So again, it's having events like this are an important part of that that fundraising process to go through there, that people can see that we're actually doing stuff with it and spending the money wisely. They feel more comfortable giving us the money, knowing that what the next thing we're going to do, if we're going to do a set of cylinders or whatever, the engine truck, trailing truck, the tender, whatever we're going to do next, what we say we're going to do with the money, we actually do with the money. So that's been a big part of it. So what's always interesting is you never know who's going to show up at these events, or what they're going to bring with them, or what stories they're going to have. Yesterday, a gentleman showed up, pickup truck, pulled in, and says, "Hey, come here, you got to see what's in the back of my truck." And I've known the guy for a long time, and I'm like, he's a character. Like, you never know what he's going to have. Sometimes it's scary what he has in the back of his truck. Pulls up, he has this big beam in here. So what in the world is that off of? Penske T1. He got that 50 years ago, pulled it out of a scrap line when they were scrapping T1s, and just kept it, and he's had it in his barn for 50 years on that. So he pulls out, donates it to us. This is the largest surviving piece of a T1 outside the trucks, the tender trucks from a T1 that are over at the Altoona at the museum. That's underneath the Queen Mary flat car. Those trucks that are underneath the Queen Mary came off of Penske T1 or J1. Some of them came off J1, some off of a T1. Right. But so other than that, this is the largest piece of locomotive that is left. Penske is very efficient when it came to cutting up engines. They cut them all up, man. There's nothing saved on it, and it's unfortunate for us. Some people say, "Oh, you're rebuilding the locomotive." No, we had nothing to even start with to even rebuild. So it is a new build locomotive, not a rebuild when it comes down to that. When you're building the frame, it is a big chess piece. You're thinking 5 to 10 steps ahead every move you make, because everything you do is going to have consequences. So if you put the wrong plate in and weld it in, the next plate you may not be able to get in and actually weld it out. So you have to be thinking, like, what am I doing next? What am I doing next? And so we went through the process, and he was staying there, our chief engineer is down here somewhere, and he went and laid out and built the whole thing in the computer, part by part, checking that every weld is going to be able to be made correctly and efficiently through the whole thing. And then we produced a series of 178 drawings, step 1, 2, 3, 4 of the order of operations to manufacture this frame, and then gave that to the shop. Typically a shop would do that. We did that for them. That keeps our costs down dramatically. So the easier you can make it for the shop, the better off you are, the cheaper you're going to get the job. So the less that they understand when they're getting the job, the more they're going to charge you for that, not understanding that. So that's a big part of it. So stuff like in these two big pockets, that's where the wheels go and ride up and down in the drivers. This piece in the middle here, we've left that in. That will be cut out. But because of all the welding and everything goes on, everything moves and around as you're welding stuff. We left it in there to keep this, hope maintains these parallel, keeps them in the same plane. Once everything gets welded out and is pretty secure in there, we'll come through and cut those off, and then we get the inner pieces welded, and the machine pieces on the other side, you can see over there, will get put on there, and that'll hold that all in place. But the frame doesn't actually sit on the wheels on that, which is, there's a big spring on top here that transfers up and goes over to, there is a equalizer, the bar that goes through here that's pinned in the middle. All the way to both these two drivers gets put on the frame right here. So this one pin that goes through here will hold about 90,000 pounds, and the one on the other side holds 90,000 pounds of weight moving back and forth, rotating on itself on there. So everything gets transferred to those on there. The frame doesn't actually sit directly on the wheels themselves. It gets transferred through a bunch of springs on there, equalizing to keep it under control. That's going down the track. So it keeps the water from slot. If it was hard, if the frame sat hard on the wheels, every little bump in the rail, every joint in the rail would go up and down, and that water would just be sloshing like crazy in the boiler, making it very difficult to operate. So by springing this gives it the suspension that the wheels can move independently of the frame, keep it smoother going down the tracks. The faster you go, the smoother it becomes on that. So they tell us. This cross is an extremely important piece of the entire design of the locomotive. And there'll be another one in the front. This is where the cylinders are going to be mounted. So we manufacture the cylinders for the locomotive. Over here, so where I'm standing is where the cylinder bore will be, and there'll be the piston going back and forth right here, driving those two wheels. Another one up there driving the front two wheels. So what you have is that all this dynamic motion going back and forth here with the piston, that creates a lot of stress. You need to transfer a lot of that stress, the force, to the frame itself on that. So what happens is the steel comes through, goes this side, the other side comes through, it sticks out of here a little way, basically like a key way. So the cylinders will slide in over top of this on there, and then the forces get transferred from the cylinders to the frame through that. All the weld is there, as the weld is just kind of holding it in place and keeping it from falling off the locomotive. All the stress doesn't go transfer through the weld, it transfers right to the steel and the frame itself on that. So very critical part of it, because you have upwards of 1 million pounds of force going back and forth on here, especially the higher speeds. You need to transfer that to the frame as best you can to propel you, because you're taking that from the piston on that, transferring it to the frame, which goes to the drawbar, which goes to the coupler at the end of the tender, which then goes to your train the whole way. So all the stress of pulling the entire length of the train. So say you have 20 to 30 passenger cars behind you, you're running 5,000 to 6,000 tons back there behind you. All that weight gets transferred right to this. So a very critical part of the frame, how it's designed, and a lot of engineering went into that to make sure that that is not only is it adequate, it meets and exceeds any factor of safety, at least 4, if not, well, we try closer to 10 on it, so to make that happen. Some of the other things, as you walk up by here, you see a skid of parts here. These are what's called the binders. Each one of these are critical, and they go underneath each of the wheel sets on here. And what that does is, again, keeps these in parallel with each other when you're going down. So if you take a wheel out and have to do work on the wheel or underneath the locomotive, the frame will tend to spread just because of the weight of the thing on it. So these keep that from spreading. It keeps it held back in place while it's in operation. As soon as you take this off, the frame will spread. And these have a tapered surface on the outside, which draws that back in and pulls the frame back square so it stays straight. So it's a critical and the component. This one skid cost us $22,000 of just the machine parts of what you're looking on this one skid. So you can kind of see the idea of how much stuff costs to make this thing happen. Like I said, well, $300,000 of this whole thing when it's all said and done, between all the machine work and all the fabrication. Well, instead of air compressors on the front of the engine that we talked about before, and then also the steam generators get mounted up there underneath the front prow, the cowling on the front of the locomotive as well, too. So, any other questions on this stuff? The boiler is in St. Louis, Missouri, at a boiler shop called Continental Fabricators. Big boiler shop, one of the largest in the country on that. The cab is up in Chicago, Illinois, stored at a shop. The guys with the air compressors being restored at that same shop. The tender is in Buffalo, New York, on a siding up there, just sitting there waiting its turn to get restored on that. And then obviously the frame is here. And then we have skids, hundreds of other parts, pins, bushings, other little brackets and stuff like that, on skids stored in a warehouse in Dover, Ohio. Any questions? Yeah.
I got a question real quick. So, from what I'm reading and whatnot, it said something about aiming for 2030. Are you guys still at route 2?
Yeah, 2030 is still our completion date. We have not changed that. We have not wavered on that. So far, we're on target. Like I said, 24 to 30 months from now, we will be setting this frame on the drivers and a boiler on top of the frame. Once that happens, then we can start doing all the plumbing and connecting everything together to make this thing reality. So that's the next phase of this project. So, but right now the cylinders are the next phase. Next 2 steps on making the cylinders. You'll see us working on that through the end of the year, and hopefully attaching them sometime in the first quarter, second quarter of next year, and then doing the axles on the wheels with the bearings and the boxes that go on that to hold them in the frame. So that's next after the cylinders. So
I got one more for you.
yeah.
From one of my guys here. Are you guys planning to do any kind of special collaborations, such as model companies like producing on Broadway Limited imports or anything like that?
We've talked to them on that and approached on that. We're not opposed to it, so we've talked to them. It just never has happened on that at this stage of the game. So we are working with K&L Trains, doing one for the video game. People can download. A lot of people play the Trains games. Trains, K&L Trains going to do the model for us.